All right, so we talked about experimental design. Now we want to talk about how to choose your participants for a survey and how to maybe set up your observational studies. And this is different. Remember, we're not going to impose a treatment. We're just going to either ask some questions or observe a population or a sample from a population and record some data and make some decisions based off of that, right? So, again, the idea behind a sample survey, which is an observational study, is to draw conclusions about a whole population. We want to choose a sample, and we want to do that from a large, varied population. And it's not really that easy, right? There's not really a best method. It's pretty tough, right? So what we're going to do to set up our observational study or our survey is to define the population, just like we did before. Define a population, say what we want to measure, and then we're going to use an organized plan to choose a sample that hopefully is a good representation of the population, and then start to measure those things that we want to measure, okay? There are some ways to do this poorly, right? And they're used all the time, actually, because they're really, really easy to use, right? There's a convenience sample, right? A convenience sample just means you're going to ask the people that are the closest to you, right? So it's say you want to survey the school on their thoughts on homework, right? And you decide you're just going to ask all of your classmates that's sitting in class with you right now. That would be a convenience sample. Not very good because you're looking at talking to a lot of seniors, and they're going to have one point of view different from maybe freshmen, sophomores, and juniors. And so while it's easy to sample that particular or to survey that particular sample, it's probably going to give you some fairly biased results, right? So in word bias comes up there. A study is biased if it systematically favors one particular outcome, right? So if you ask all the seniors their view on homework because they've been in school the longest, their results are going to sort of lean one particular direction for the most part. It's not going to be true for everybody, but for the most part, seniors are going to think alike, so they're going to give you one particular outcome that could very much be different from the entire population of, say, the school, right? The other method is a voluntary response sample, and this gets used all the time. Most of your online surveys where you read an article and there's a little survey in the margin that you click your response to anything that's posted in Instagram that is going to be a voluntary response sample. It's basically where the participants choose whether to join the sample or not, right? The people choose themselves. The issue there is the only people who are really going to respond are the ones that have a really strong opinion, and most of those times that strong opinion is going to be in one direction, right? It just very much depends on the question being asked, but if you're not actively trying to seek people that may think both ways on a particular question, then you're allowing people to decide whether they're going to answer themselves, then you're probably going to get results that lean one way, okay? So to combat that, right, to combat a convenient sample or a voluntary response sample, a true statistician is going to allow impersonal chance, so that you're not likely to get the same answers out of your survey one way or another. Impersonal chance implies randomness, right? Random cures all in statistics, right? So we're going to use a random sample. In other words, we're going to use random chance to produce our sample and hopefully give us a clearer idea of what the population thinks, right? The easiest type of sample to produce the same, and what I mean is the easiest way to decide which participants should be in your observational study is what's called a simple random sample, and sometimes called an SRS, or a lot of times called an SRS. That's where everyone in the population has the same chance of being chosen, regardless of whatever. And the most basic form of an SRS is just pulling names out of a hat, right? That becomes problematic too. I mean, that's your most basic non-digital way to create a simple random sample. In practice, right, in theory, that's what we basically do. In practice, people use random number generators by a computer or a calculator, and we're going to use our calculator and talk about how to do that to choose samples. Okay? Simple random samples are great. They're very easy to at least produce or to help us decide which participants to choose for our sample survey. Unfortunately, you still have a pretty decent chance, or you run the risk of creating a sample that all shares one same characteristic and may favor one particular outcome. So sometimes more complex sampling methods need to be used. One alternative method to a simple random sample is what's called a stratified random sample. A stratified random sample involves us taking the population and breaking them up into groups that share a particular characteristic, right? You go back to the homework question. So if we don't want to do a convenient sample because we're only going to ask the people in the classroom and those are only going to be seniors, then what we can do is we can break the school up into our strata. And a strata would be your age groups, your grade levels. So freshmen, sophomores, juniors, and seniors. And then what you do is you create a simple random sample within each of those groups, combine those individuals into our giant sample, okay? So choose a few freshmen, a few juniors, a few sophomores, a few seniors, and combine those guys to create our sample, okay? We'll go through examples of these in just a second. So that's one alternative method. The issue with a simple random sample and a stratified random sample is that sometimes your participants can be really spread out, right? And so you're going to have to walk all over the school building to find those individuals because very often the mixture of those age groups are not together in one spot. So that being the case, if we want to try to create a sampling method that would make it a bit easier to go actually get our participants, then we can use what's called a cluster sample, right? Here is where we're going to section off the population into smaller groups called clusters. And hopefully the idea behind sectioning off these smaller groups is that the smaller groups still very much look like the population. They have a good mixture of everybody in there. And so once we get those sections and they're a good mixture and look like the population, then we can just randomly choose which of those clusters we'll combine to make up our sample, okay? In the building, where are you most likely to find a good mix of freshmen, sophomores, juniors, and seniors? Right? Well, think about your lunch blocks, right? Your ABCD lunch blocks. There's probably a pretty good mixture to where each block in the cafeteria is going to look pretty close to the population, and so maybe we randomly select one of those lunch blocks if we want to talk to students about their feelings on homework. Okay? And then another way to sample, and kind of runs into the same issue with SRSs and stratified random samples, is systematic, where you may have to walk around place to place, large distances to find your participants. But a systematic sample is easy to set up. you're just going to basically number off the population and then decide to choose your participants based off of a pattern. For example, you'll go through and choose every third member or every fifth member of the population, right? Since the population isn't sectioned off by any characteristic, you do still run the chance of providing a sample that's not very representative of the population, but it's easy to set up and pretty easy to carry out, right? So examples of all of those different types of sampling methods, right? So let's say that we're having an all-school assembly and we're in the auditorium. The auditorium, all of the seats are numbered off. So we want to choose 80 students, right? Well, there are 800 students in the auditorium, and we have grouped them all. So we've grouped them down here. You can see where all of those students are sitting. So seniors, you're in seats 1 through 200, and so on and so forth. You can see that, right? Now, to produce a simple random sample, we're simply going to randomly choose 80 numbers. We're going to plug into our calculator and into randint, which you're going to find out about pretty soon, and ask for between 1 and 800. Just give me 80 random numbers, seat numbers, to go choose. So you might get a participant that's sitting here in seat 2. You might get one that's sitting in seat 331, one that's sitting in seat 786, and maybe over here, so on and so forth. Okay? That's what a simple random sample is, right? Now, since you're just asking at random for 80 numbers, is it possible that all 80 of your numbers fall into one section, right? Is it possible for all 80 numbers to be between 1 and 200? Yeah, it's possible. Probably not very likely, but it's possible. So that's what I was saying before about how a simple random sample still may give you a sample that's not very representative of the population, right? All right. The next one is a stratified random sample. Okay, so if we're worried about making sure we get a good mix, then we'll create strata, right? And strata is where we're going to take our population and section off by a particular characteristic, right? So that everybody in our strata share a characteristic. And we've done that down here already. By seating all of you guys with your grade level, we've created strata in the form of those sections: 1 to 200, 201 to 400, 401 to 600, 601 to 800. Okay, so now what we're going to do is, if I want 80 students, I've got 4 strata. I'm going to randomly choose 20 from there, 20 from there, 20 from here, and 20 from here, right? And so I still have to maybe I'll probably have to walk all over the place still. I'll probably choose this one, this one, this one. I might choose this one. And then there'll be one here, maybe there. And then there'll be one maybe here, and here, so on and so forth, right? So we're still going to walk all over the auditorium trying to find our participants. But we're at least going to have a really good mix, right? We've got 20 in each group. That's a stratified random sample, okay? A cluster sample means that we're going to section off to where we've got a good mix of a good mix within a smaller group, so that our smaller group looks like our population, right? So there are 800, let's see. If we're going to look for 80, then how in an auditorium are the seats situated to where if you choose a group, that group should be a good mix like the population would be, right? So the population's all freshmen, sophomores, juniors, and seniors. Which grouping would give us a mix of freshmen, juniors, seniors, and freshmen, sophomores, juniors, and seniors? Well, hopefully you're thinking about not rows, but columns, right? So columns, let's see. Okay, so maybe we choose everybody, or not, we can't just pick which spot. So we're going to randomly choose a column, not a row, but maybe we'll randomly choose a column that might be all of the seat numbers ending in 0, right? So all of your multiples of 10. That's going to give you 40 participants here, and then you're going to come over here and get 40 participants over there to make your 80, right? And it's 40, it's hard to see, but we've got 10 and 30, right? And then 50 and 70, so these columns are a little bit weird, but in each column you're going to have 40 participants, right? So since we're looking for 80, we're going to get 2 of those columns and just go straight down a column instead of a row, right? And if you get 2 of those, one from each side, then you'll have a good mix of juniors, seniors, sophomores, and freshmen. All right, and then last but not least is our systematic sample, right? Our systematic sample means that we're just going to choose since there are 800 people and we want 80, then we could choose like every 100th, sorry, not every 100th, every 10th person, right? Which means that we would select this one, and then this one, and then this one, and then this one. That would kind of produce the same as the cluster if you end up with those same columns. But you don't have to start at 0. You can maybe start here and take every 10th one, right? So you would take number 2, and then 12, and then 22, and 32, so on and so forth. So every 10th, right? Or every 4th one until you get your 80 or whatever, right? So that's the pattern that you want to use to create your systematic sample. All right? Even with the best sampling techniques, sometimes your sample surveys are affected by errors, and that's where the margin of error comes in from the previous video. Those can still come up and haunt your surveys, so you got to be careful, and that's why we include a margin of error. Sometimes there's under coverage where when in your population there may be groups that, because of your sampling method, gets left out of the process on accident. There's non-response when you choose your sample and then you go to ask those people the questions that you want to ask them, they just don't answer. So you're automatically affecting your sample, your results that way. There's a response bias where people may give you incorrect responses or incorrect answers, either because they're embarrassed or they don't understand the questions, or they just want to mess with your sample, your survey. And then sometimes the wording of questions influences the results one way or the other. So there's still can be some things that can go wrong even when you sample really, really well. That's why we want to make sure that we include a margin of error. Okay? And that's how we're going to set up our sample surveys.